Basically, what we're talking about is having two atoms where the arrangement of their nuclei and their electrons are such that the bonded atoms result in a lower energy than for the separate atoms. So we know we always want to have our systems in as low an energy as possible, so it makes sense that a bond would happen anytime we get a lower energy when we combine two atoms versus when we keep them separate. So specifically, today we're going to talk about covalent bonds. A covalent bond is any time we have a pair of electrons that is shared between two different atoms. And the key word for covalent bonds is the idea of being shared. One electron, or the two electrons, for example, we see in the H2 molecule, they don't belong to one or the other atom, they're actually shared. And what we'll see later is that this sharing is not always equal. In the case of H2, it is completely equal sharing. In some cases, because of things like electronegativity, one atom will take away more of the electron density than the other atom, but they're still shared even if they're not always evenly shared. So in talking about covalent bonds, we should be able to still apply our more general definition of a chemical bond, which should tell us that the H2 molecule is going to be lower in energy than if we looked at two separate hydrogen atom molecules. So let's see if that's actually the case. So if I tell you that the energy for a single hydrogen atom is negative 1312 kilojoules per mole, if we want to talk about two hydrogen atoms, then we just need to double that. So that's going to be negative 2624 kilojoules per mole that we're talking about in terms of a single hydrogen atom. So let's compare this to the energy of the H2 molecule, and we find that that's negative 3048 kilojoules per mole. So in fact, yes, we did confirm that these covalent bond, at least in the case of hydrogen, we have confirmed by the numbers that we are at a lower energy state when we talk about the bonded atom versus the individual atom.